Let's learn about logistic regression. So what is logistic regression? Logistic regression is a standard classification machine learning algorithm. Like linear regression, logistic regression finds weights for each column of data. So far, they're the exact same. But unlike linear regression, logistic regression splits the data in half. So how does it do this? Well, logistic regression uses something called the sigmoid function, which we'll go over. And that's designed to convert all of the outputs into 0 or 1. So in machine learning, 0 could be the absence of something, 1 could be the presence of something. You could be trying to predict whether something is present. And so your output, your Y value is all zeros and ones. Well, logistic regression is designed to handle this kind of a data set. Now, because of this, basically it classifies the data into groups. And when it's doing this, it's actually recognized as a classifier using machine learning categories. Okay, there are classifiers and there are regressors. And so despite its name, logistic regression is actually a classifier. Now you might wonder, but why would it be called a regression if it's a classifier? Well, math has sort of like its own class, you could say categories of names, which is a little different than machine learning. Regression sort of has a general meaning, like regression to the mean is like a convergence toward a mean value. Regression to a curve is a convergence toward a curve. And logistic regression, as we will see, is a curve. Okay? So more on regressors and classifiers later. But for now, let's take a look at the equation that is sort of the centerpiece behind logistic regression, which is the sigmoid. So here's a nice visual of the sigmoid. This is using t as your sort of x value. And so as you can see, it's 1 over 1 plus e to the negative t. E here is the 2.718 transcendental number. And this is the visual of it. You can see it is in fact bounded by 1 at the top and 0 at the bottom. And so there are two asymptotes. And so even though the curve here, like it stops at 8, like it keeps going. There's not a limitation to any value of t that you can put in here. Okay, so what about these positive x values here? What can we say about them? Well, they are mapped to class 1. You can see even though you get a range of values, here we're looking at the y, so any x input, you're getting all different y values, but in logistic regression, these are all then mapped to class 1. Okay, whether you're down here or up here, the output is going to be 1. That output is not the sigmoid, that output is logistic regression. It advances the sigmoid, an extra step. Okay, now what about the negative x values? Well, you can probably predict what is going to happen. The negative x values are mapped to class 0. Okay, here we're using capital X, which is the norm for the machine learning model's input. And there's actually, some math that happens. Okay, the weights are actually found first, and then they're transformed. It's basically a 3-step process. First, you find the weights, then you put them into the sigmoid, and then finally, you just give 0 or 1 based on this negative positive classification. Okay, now what about these x values kind of in the middle? Well, they're to both sides. So how might we interpret those? Well, you could say that they have the greatest uncertainty, right? Because if you look at, say, this between like 1 and negative 1, like those values are closer to each other than potentially between 1 and 8, right? And 1 and 8, the point here is that those are all positive, whereas 1 and negative 1, some of those are positive and some are negative. So the uncertainty actually matters here And so basically, probability is going to play a role. Okay. So, as mentioned, the values can be interpreted as probabilities. And let's take a look now at how this plays out. Okay. So here is an output to our logistic regression model. Before coming into the sigmoid, it looks like it has a value of approximately 5, and the y value is 0.98. So you interpret this as actually a 98% probability that it belongs to class 1. Okay? This is by design with the model. Down here, okay, we have another value after it goes into the sigmoid. The y value is 0.2, so we would say there's a 20% probability it belongs to class 1. Conversely, an 80% probability that it belongs to class 0. Okay. What about this one? It's kind of like right in the middle there, but you can see it is to the right. And so because the probability is in fact greater than 50%, it will go to class 1, but the uncertainty here is clearly greater. Okay, so let's just look a little bit at, so what's happening here? How is logistic regression working? Well, the weights are randomly chosen initially to multiply each column. This is just like with linear regression. Okay, this is how you start. Now, the weighted columns are summed. This is also just like linear regression, okay? Same stuff so far, but the sum is placed in the sigmoid equation as shown in the previous slides and then mapped to 0 or 1. This is what makes it a unique model, okay? Next, okay, so right, if you randomly choose the weights, you're probably going to get major errors. It's not going to do very well. And so this is now similar to a lot of machine learning models, including logistic regression. You're going to look at the error. There is an error function that uses the log loss, which is a probability function. And what it's going to do is go back and adjust the weights accordingly using gradient descent. Okay, and the idea of gradient descent is just to sort of go toward the minimum, adjust. If you're too high, go down. If you're too low, go up, this type of thing. And basically, you go for another iteration, right? You adjust the weights and then you do this again. You multiply them by the columns. You sum the columns together, right? And when we're doing this, think about it like a row at a time. So, each individual row has sort of like one number that's going into that sigmoid, and that's going to end up in this 0 or 1, okay? And then, of course, you just keep going. This is back propagation. You go back. You continue to update the weights until you minimize the error, until there's convergence, Convergence here meaning like instead of like wild fluctuations, you start to narrow down to an actual value. Okay, and so that is the gist of how logistic regression works. The key here that I want you to take away is that at the beginning, it actually is the same as linear regression. It's just multiplying and summing, but the key difference, okay, to get it to this kind of unique 0, 1 is, hey, let's use the sigmoid, which is bounded by 0 and 1, and then we can conveniently map the positive outputs to 1 and the negative outputs to 0. It's a very nice way of sort of looking at it, where we figure this out by adjusting according to the probabilities, and the probabilities are meaningful when it comes to making the predictions. And you continue through this process until you get convergence. And there you have it.